A stateful bean is written almost exactly the same way as a stateless bean. The only difference is that it has some local storage. As an example of this, I'm going to show you the source code of a stateful bean and then show you an application that uses two separate instances of it. This is the interface that specifies the methods of the bean. This bean represents a rectangle of a specific height and width. The methods setHeight and setWidth store the height and width values in the bean, and the method getArea returns the area of that rectangle. Simple, but it does mean that the bean holds information put there for later retrieval. Here is the home interface for the bean. Except for the name of the class, there is no difference between this code and the one in the previous example. It's just the create method declaration. Here is the bean itself. It's the same as any Java class. The setWidth and setHeight methods accept an argument value that is stored in local memory. The storage is private to the class. These are the values that will be serialized when the bean is passivated. Notice that there is no code in the EJB passivate and EJB activate methods. Nothing is needed here because the int values can be serialized and stored without any help. The only method in this bean that returns a value is the getArea method. All it does is multiply the two values together and return the result. There are some minor modifications that need to be made to the XML file. This is a copy of the XML file that was used in the previous example, except all the occurrences of the ccount name have been changed to rect, and there is one other change. This entry has been changed from stateless to stateful, and everything else in the file is the same. There is a single build bean script that sets the class path and compiles the Java source into the class files of the bean. The deployment of this bean is fundamentally the same as the previous one, but there is one important difference. During the configuration, this button was set to indicate that this is a stateful bean, not a stateless bean. The rest of the deployment sequence is pretty much the same. In the upcoming windows, you run the verifier to make sure everything is set up right and then deploy it to the server. All we need now is a client that uses the bean, and just like before, that's the easy part. An initial context object is used to retrieve a reference to the object that manufactures the beans, and the object then is narrowed into one that can be used inside this program. In this example, we retrieve two references to a bean, and since this is a stateful bean, that means there are two instances of the bean created inside the server. These statements prove that there are two separate beans. First, the area returned from both beans is printed. They are, of course, both 0 at this point. The first rectangle has its height set to 5 and its width set to 10. The second rectangle is made into a square by having both its height and width set to 3. Now, these last two print statements print the area of each of the two beans, and if they are separate beans and the server has kept track of them properly, they'll show up as two separate values. The script that builds the client sets the class path to the J2EE jar file and to the jar file that was returned from the server specifically for this bean. Then, setting the class path to the same thing again makes it possible to run the program to create the two stateful bean instances. As you can see, the two beans were kept distinct from one another inside the server, and each one maintained its own set of values. This was done by creating a couple of bean references inside one program, but it could have just as easily been done from two separate programs, or 3, or any number.